exhaust, it just smells like a little bit of steam.
When you burn hydrogen, the product is water vapor, which is a natural constituent of the environment. It's recycled in nature. It's already there. It comes back to us as rain. And producing a lot of hydrogen and then burning it as fuel is really not going to materially change anything that's already going on in the earth. As a matter of fact, the oxygen that is used to burn hydrogen, if you're producing your hydrogen from water, you are co-producing the oxygen.
Mr. Sandy Stuart, president of Electrolyzer Incorporated, was the chairman of the 5th World Hydrogen Energy Conference. Over 500 delegates from around the world came to Toronto for a week in July 1984 to discuss the production, storage, and uses of hydrogen. This conference dealt with the vital challenge of supplementing or replacing the world's finite fossil fuel supplies with hydrogen. Hydrogen can be used in the applications that now use oil, gasoline, or coal, and it can be made in massive quantities from water using the world's sustainable sources of energy, such as existing nuclear fission, hydraulic power, the sun, and someday perhaps nuclear fusion or even the ocean tide. In Canada, our abundant sources of electricity provide us with a distinct advantage to play a leading role in new hydrogen technologies. Research on hydrogen has already begun at the Institute for Hydrogen Systems under the direction of Dr. David Scott.
Hydrogen is not a source of energy. Hydrogen is what I would call an energy currency, just like electricity is an energy currency. You need a source of energy, whether that's hydraulic or nuclear or coal, to make electricity from, and you will need a source of energy to make hydrogen from. But therein also lies its power. In other words, the difficulty with our new hopes for the future, whether that is fusion or sunlight or wind, is how do you take a little bit of wind and put it in your gas tank, or a little bit of sunlight and fly an airplane with it. And of course what you have to do is take those energy sources and split water into hydrogen and oxygen, and then use the hydrogen, either neat, like you drink whiskey neat, to fly the airplane or put in your car, or tie it to carbon, that is our hydrogen-deficient fossil fuels, and buy time and make more gasoline.
What we have here is essentially a Datsun or a Nissan Maxima. It's originally a turbocharged diesel 4-cylinder engine car. And Professor Furuhama from Musashi Institute has designed, and his students have manufactured, a cryogenic liquid hydrogen pump, which is installed in the rear of the vehicle, which takes atmospheric pressure hydrogen and pumps it up to about 1,200 pounds per square inch pressure. And the hydrogen comes to the front of the vehicle, where it is heated up into a room temperature gas at 1,200 pounds, and it is supplied to the diesel injectors, which have been designed by the students at Musashi Institute in Tokyo.
A unique event at the conference was the display of hydrogen-powered vehicles at the University of Toronto. 6 cars and a tractor, representing current technologies in 4 countries, were brought together here for the first time ever. Unlike these retrofitted internal combustion-powered cars, and except for special cases, we expect the hydrogen car of the future will be powered by highly efficient fuel cell technology. However, the way hydrogen will be stored in those vehicles and the materials that they will use will evolve from the research of dedicated teams like these. The car stimulated a great deal of discussion among delegates and members of the public, and many people took advantage of the opportunity to go for a drive in one around the university campus.
There are different fuels, for example, gasoline, or liquid natural gas, or liquid hydrogen, and all 3 of them are absolutely comparable in safety. Hydrogen has some adverse properties, gasoline has some adverse properties, but in the average, it's about the same.
This tank, called a dewar, is a vacuum-insulated, super-insulated tank. There's an inner vessel made of stainless steel. It is surrounded by so many, I would say about 50 layers of super insulation, which is a mylar, aluminum-type foil, and a glass fiber, alternately placed. And then there's an outer vessel of aluminum. It is evacuated very low vacuum. And it contains the liquid hydrogen at about minus 250 degrees C.
One business with a long history in the hydrogen industry is the Electrolyzer Corporation of Toronto. Founded in 1948 by Mr. Alex Stuart, Electrolyzer today serves more than 600 industrial and utility customers in over 80 countries. From experiments dating back to 1905, this pioneer developed the patented Stuart cell, which now produces high-purity hydrogen gas from water by electrolysis. The Electrolyzer Corporation also manufactures gas compression systems and oxygen-hydrogen gas plants. Hydrogen is already an important industrial commodity, and Stuart cell electrolyzers are used throughout the world to produce hydrogen for nylon, margarine, shortening, fertilizer, glass, light bulbs, microchips, and 100 other products. But in the long run, electrolytic hydrogen will be most important as an alternative fuel. There are already countries with an abundance of hydraulic and nuclear electricity, but low supplies of hydrocarbon fuels. They are actively exploring the electrolysis of water. With the support of the Government of Canada and Hydro-Quebec, the Electrolyzer Corporation and Noranda Mines have worked together for almost 10 years to create very large-scale electrolysis systems to meet the impending demand. On a smaller scale, academic research associates and the Electrolyzer Corporation are developing a hydrogen-powered tractor specifically for use where electrical resources are plentiful and imported oil is very expensive.
The Rockhaven Farm hydrogen-powered tractor demonstrates the possibilities of using hydrogen as an alternative fuel to gasoline. This particular machine is designed to operate on either a hydrogen mode or a gasoline mode. And hydrogen is stored on board the tractor in a metal hydride bed which receives exhaust heat from the manifold, which heats the hydride and releases the hydrogen off the bed.
Well, Mercedes-Benz has done a lot of research and development work in the field of hydrogen drives concerning both storage, safe storage of hydrogen on board a vehicle in metal hydrides, as well as the use of hydrogen to fuel an internal combustion engine. Our experiences with several test vehicles, experimental vehicles, were the starting point to participate in a field testing program called Alternative Energies and Road Testing in Berlin, sponsored by the Federal Ministry for Research and Technology in Germany.
The hydrogen-fueled cars, for an example, which we have as part of our Institute for Hydrogen System, that's a liquid hydrogen-fueled Buick. In other words, it was originally designed to run on gasoline, and we changed the tank and now run it on liquid hydrogen. But the reason for that is to gain experience in learning how to carry liquid hydrogen on board any vehicle, whether that's a train or a ship or an airplane. It is not, and we should emphasize this, there's no possibility that people will be driving liquid hydrogen fueled Buicks around in an economic sense. In other words, we can drive them and we can do it, but it doesn't make sense. If you want to use non-fossil energy to drive a Buick, your best way is to take some hydrogen that you've made from splitting water and add it to a fossil-deficient hydrocarbon resource, you see it in fossil, and make more gasoline. And that's the economic way of doing it. More feasible is that you should look for opportunities where hydrogen provides a unique advantage. What I call a hydrogen leverage setting. I'll give you a couple. One is an airplane, because therefore the light weight, and hydrogen weighs about a third of kerosene, has enormous advantages. In other words, really, when we fly airplanes to Europe, we're not jetting people, we're jetting kerosene. There's over 200 tons in those airplanes of kerosene. If you collapse that to 1/3 of that, then you can make a smaller airplane, a more efficient airplane, and the hydrogen becomes a much more valuable fuel. Do you see what I mean? Because you have a technology that can exploit that.
The transition to a world hydrogen energy system will evolve over many decades. Initially, hydrogen from non-fossil energy sources will be used to upgrade heavy oils, tar sands, or even coal to conventional synthetic fuels. Eventually, pure hydrogen will form the basis of a truly sustainable, non-polluting global energy supply. The existing industrial demand for hydrogen will allow research to continue and permit the evolutionary introduction of the new hydrogen technologies of tomorrow.
It's an interesting point that Canada has abundant energy resources of all kinds. We've got an opportunity to mix them, to create synthetic fuels, blending electric-based fuels with hydrocarbon-based fuels. But central Canada, the indigenous energy of central Canada, Quebec, Ontario, Manitoba, is in fact electricity, hydroelectricity or nuclear electricity. We are therefore particularly well placed, and we always have been, to develop electro-technologies, ways in which electricity's application to society can be extended, how electricity can be made more important to the economy by bringing it out in new forms. And hydrogen is one of those forms. The development of energy from electricity in fuel forms is therefore a very natural thing for Canada to play a leading role in. Are they demonstrating?
The holy grail for the auto industry is a zero-emission vehicle, one that's environmentally benign from producing the fuel to driving the car. Now, the solution would seem to be a solar car. Unfortunately, directly converting the sun's energy is still in the hands of science fiction writers. But one Canadian company may just have the answer to a slightly different solar car. They're using the sun's energy and one of the most abundant elements in the world, hydrogen. This is electrolysis. It uses direct current electricity to split water into its component parts, hydrogen and oxygen. The concept is as simple as a school chemistry project and has been around for more than 200 years. In the search for alternative fuels, hydrogen is being touted as one of the best, and so efforts are underway to determine how well hydrogen works as a fuel for the internal combustion engine. In Riverside, California, a study is underway to evaluate the success of running this modified truck safely with hydrogen. Renewed interest in hydrogen has been sparked by stringent emission control regulations in effect by the end of the decade. So far, hydrogen is fulfilling a promise to reduce tailpipe emissions.
Our vehicle is using hydrogen as a fuel, and hydrogen has no carbon atom. We found that the carbon atom in the fuels is usually what causes most of the components of smog. We get carbon monoxide from the carbon atom, we get the hydrocarbons, we get the particulates. All of these that are dangerous to public health are a direct derivative of carbon.
At the moment, the test vehicle is using commercially produced hydrogen from a local chemical company. But traditional methods of producing hydrogen are contributing to air pollution. So researchers here have decided to try something different. They're taking their test to another level.
What makes the Riverside project unique is it'll be the first time, to my knowledge, in the world where we'll be taking the sun's energy, converting that to hydrogen, and storing it on board a vehicle to be used in transportation. So the vehicle will be almost zero emission, and the way that the hydrogen is produced is essentially zero emission, because it's just the sun's energies.
At the Electrolyzer Corporation in Toronto, this experiment demonstrates that even on a winter day, solar power can make hydrogen. Hydrogen is being released at the cathode on the right and oxygen at the anode on the left.
I've got here a prototype just to demonstrate the concept of what is solar hydrogen. We see here the sun's energy is hitting this solar panel. It's an amorphous silicon solar panel, and it's making direct current electricity. The electricity is going into a water electrolyzer. It's a very small 2-volt, few hundred watt system. And here we see we have a feed water bowl on the cell, allows water to come into the cell. There are 2 balloons here. One is holding hydrogen and the other is holding oxygen. Also, you note that the hydrogen balloon is about twice the volume as the oxygen balloon, because when in water electrolysis you take H2O and you make 1 oxygen molecule for every two hydrogen molecules. So these balloons essentially represent stored sunshine. I've got a very simple demonstration where I'm going to take my hydrogen energy, and first I'll demonstrate. I've got a little glass tube here which I'll ignite, and I've got a clear hydrogen flame. You cannot see it. We can go, if we're in the Arctic and we want to dig a hole in the ice, I can melt some snow. Another application, of course, would be in the Riverside hydrogen car project. This will be solar-produced hydrogen will be burnt in an internal combustion engine to give you useful motive power to let you drive your car somewhere.
This is the business part of the hydrogen vehicle. As you can see, we're getting water vapor instead of smog. I can show you that you can breathe this water vapor, which you should not try to do from the tailpipe emissions using fossil fuels.
While water
Lorsque l'hydrogène est exposé à une flamme, en présence d'oxygène, il brûle vigoureusement, souvent de façon explosive, en produisant de l'eau. Lors de cette réaction, 2 atomes d'hydrogène se combinent à un atome d'oxygène pour former une molécule d'eau. Cette combustion ne donne lieu à aucune pollution et la quantité d'énergie émise est beaucoup plus grande que lors de la combustion de l'essence. C'est pourquoi l'hydrogène représente une ressource énergétique prometteuse. Plusieurs méthodes ont été développées pour obtenir l'hydrogène. La plus prometteuse utilise 2 ressources quasi inépuisables, l'eau et l'électricité. Ce procédé, l'électrolyse, s'effectue au moyen de cellules électrolytiques. Ces cellules comportent des électrodes baignant dans une solution saline. Un courant électrique intense est appliqué entre les 2 électrodes. Ce courant provoque la dissociation des molécules d'eau. De l'hydrogène se forme sur l'électrode négative. Selon le sel utilisé, de l'oxygène ou du chlore est produit sur l'électrode positive. Chaque litre d'eau fournit ainsi environ 1000 litres d'hydrogène gazeux. On sépare ensuite la vapeur d'eau de l'hydrogène produit. L'hydrogène gazeux ainsi obtenu peut être acheminé au lieu d'utilisation grâce à des canalisations. Mais il peut aussi être refroidi jusqu'à la température de moins 253 degrés Celsius. Il devient alors liquide et peut être facilement transporté. L'hydrogène est utilisé dans l'industrie chimique, par exemple pour la fabrication d'engrais. On s'en sert aussi en microélectronique et même pour la préparation de la margarine. Mais on croit que l'hydrogène, en particulier l'hydrogène liquide, pourrait devenir le combustible idéal pour divers types de véhicules. Pour fabriquer un moteur à hydrogène, il suffit d'apporter des modifications relativement mineures à un moteur conventionnel à essence. Leur grand avantage est qu'ils n'émettent aucun gaz toxique susceptible de vicier l'atmosphère. Obtenu à partir d'électricité et d'eau, l'hydrogène peut aussi être reconverti en électricité et en eau au moyen d'une pile à combustible. Dans cette pile, de l'hydrogène et de l'oxygène se combinent sous l'effet d'un catalyseur, produisant de la vapeur d'eau et un courant électrique. Celle-ci, d'une puissance de 40 kW, pourrait suffire à l'alimentation énergétique de 3 maisons, même en hiver. Les compagnies productrices d'électricité envisagent la construction de piles à combustible de grande dimension qui pourraient desservir en électricité des régions éloignées. Une des applications les plus prometteuses de l'hydrogène est son utilisation comme carburant pour les fusées spatiales. Riche en énergie, maniable et d'une grande légèreté, l'hydrogène alimente les moteurs de nombreuses fusées. La fusée porteuse de la navette spatiale américaine, par exemple, est propulsée à l'hydrogène. Le développement de ces technologies, comme celui de toutes les autres énergies nouvelles, est limité par le très faible prix du pétrole, qui encourage l'utilisation de ce dernier partout où c'est possible. Tôt ou tard, cependant, le pétrole s'épuisera et devra être remplacé par d'autres sources d'énergie, comme l'hydrogène.